So in this question, what we have is this medium is air, this medium is glass. So the light is traveling from air to glass because this is a rare medium, this is a denser medium. So the light will bend towards the normal. So this is I, this is R, and mu of glass with respect to air is 1.5. Mr. Sibang, any doubt?
No.
So effectively what we have is mu of glass with respect to air is 15 upon 10, and this will be equal to 3 upon 2. So this will be 3 upon 2. Now what they are asking is, effectively what they are asking is that they want the mu of air with respect to glass. This is the given information is that mu of glass with respect to air is 3 by 2. And what is being asked is refractive index when light travels from glass to air. So effectively this means that we want the mu of air with respect to glass which will be reciprocal of glass with respect to air. Mr. Zibang, any?
No.
So this would be equal to reciprocal of 3 by 2, and the answer would be 2 by 3. Mr. Zibang, any doubt?
No.
See, another way of looking at this question would be, if you don't want to, use this formula, another way of looking at this is, I can use the principle of reversibility. What I can say is that if the light is traveling from this angle to this angle to this angle, so this is my denser medium, this is my rarer medium. Now in this case, what I'll be calculating would be the mu of this, that is air, with respect to glass, and this would be, then this would become my sin r. This sin r would become my angle of incidence, and this I would be my angle of refraction, and this effectively is 1 upon sin I upon sin r, and this is equal to 1 upon mu of G with respect to A. Mr. Zibang, have you understood, or has this become confusing?
No, sir.
So if it has become confusing, all that you can remember is that the simple thing that you need to remember in questions like these is that if this is air, say this is water, the simple thing that you need to understand is that mu of water with respect to air is 1 upon mu of air with respect to water. It is as simple as that. Any doubt, Mr. Siva?
No, sir.
Great, sir. So the same has been done here. Simple formula has been used. This mu of G with respect to air is mu of air with respect to G. The values have been put, and the final answer is 2 by 3. Any doubt, Mr. Siva?
No.
Great, sir. Before we move on to the next question, I just want to share with you the different formulas of mu refractive index that we have in this chapter as per our ICSE class 10 syllabus. These are the formulas that we have. So this is air, this is water, this can be any denser medium, this can be any rarer medium. So the light enters from the rarer to the denser medium. The formula that I have is, so the mu would be, the refractive index would be with respect to the denser medium. It is sin I upon sin r. This is the first formula that I use. The second formula that I have is velocity in the rarer medium. This medium is 1. This medium is 2. Velocity in the rarer medium and velocity in the denser medium. Mr. Sibang, any doubt?
No, sir.
We are talking about light. So V1 can be written, the velocity can be written as F into lambda of light. Or to make things far more, far more focused, you can also take that this to be, say, let us take this to be a red light. This will make things far more focused. So velocity of red light can be written as frequency into lambda of red light in air. V2 can be written as velocity of red light in the medium. This is the velocity of red light in the medium. This is the velocity of red light in air. So this would be F lambda 1, this would be F lambda 2. Frequency of red light in both the mediums would be same. Lambda 1 is the wavelength of red light in first medium. This is wavelength of the red light in second medium. So this would be lambda 1 upon lambda 2. Mr. Sivang, are you understanding this or it is getting confusing?
Yes, sir.
So these are the formulas. These are the three formulas that we have. The fourth formula that we can use is that mu is also given as the real depth by apparent depth. This is another formula that we use in the chapter. And the fifth formula that we use in the chapter is mu of a medium is 1 upon sine c, where c is the critical angle. Mr. Sibang, any doubt?
No doubt, sir.
So why we have discussed these formulas, we will just understand this when we look at the question number 2. Mr. Sibang, question number 2.
The next of the material is going to
That is why we discussed the formula of mu. Now see, mu is velocity in air, or let us say vacuum, upon velocity in vacuum in material. So this would be material. So refractive index is given as 1.2. Velocity of light in air is 3 into 10 to the power 8, and velocity in material. So using this formula, we can find the velocity in material. Mr. Sivang, any doubt?
no doubt, sir.
So this is the working of this question. This is the working. Velocity in medium has to be found, and this is equal to 3 into 10 to the power 8 upon 1.2. The final answer would be 2.5 into 10 to the power 8. Any doubt, Mr. Sivang?
No doubt, sir.
This is the final answer. Okay, great. Let us move to the next question. Okay, can you read the next question?
Glass block 5 centimeter thick is reinstated. Calculate the height from the center to the reinstator's base if the refractive index of the glass slab is 1.5.
Okay, so we have this glass slab, which is 3 centimeter thick. Calculate the height through which the image of the newspaper. So let us assume that this point is the newspaper point. Now the refractive index of this glass slab is 1.5. Now we know that this would be the real depth, and this, of course, due to the refraction, if we are watching it from here, if this is our eye, this newspaper would appear to be a bit raised. So using the formula that we just discussed, that mu is equal to real upon apparent. We will be able to calculate the apparent. Mr. Sibang, any doubt?
No doubt.
So in this case, mu would be, what is mu? Let me clear this. So mu is equal to real upon apparent. So mu is 1.5 real is 3. I will be able to calculate the apparent. So apparent would be, yeah, this would be 315 upon 10 upon 2. So the apparent would be 2 centimeter.
Yes,
Any doubt? So basically, this newspaper, let us assume this to be any word in the on the newspaper. So this 3 centimeter, this depth would appear to be 2 centimeter. Mr. Devang, any doubt?
No doubt, sir.
And the height through which the image is raised would be shabash. Shift is equal to real minus apparent. Any doubt, Mr. Devang?
No doubt, sir.
So that is why we discuss these formulas. So this is the formula that we used in question number 2. This is the formula that we are using in question number 3. Okay, I will show you the working of question number 3 also. Let us look at the working. So actual upon apparent. So I have calculated the apparent, and using the apparent, the raised height is 1 centimeter. Mr. Devang, any doubt?
No doubt, sir.
Great, sir. Let's move on to the 4th question. Mr. Devang, can you read the 4th question? So in this question, say this is a water tank. Now there is a stone here. Yeah, this stone, the water, this is water. So the mu of water is 4/3. We want to find this is the actual depth. But the stone is, it appears that it is raised by 80 centimeters. So I'll use this kind of arrow. I'll use a single arrow so that it is clear. Now the stone appears to be at this point. So this 80 centimeter is actually the shift. Mr. Devang, any doubt?
No doubt, sir.
So the formula that we have is mu is equal to real upon apparent. This would be real upon apparent, can be written as real minus shift. Mr. Devang, any doubt?
No doubt, sir.
So in this case, the information that we have is we have mu, we have shift, which is 80 centimeter. Using this information, we will be solving this equation. We will be able to find the value of real. Mr. Devang, any doubt?
No doubt, sir.
Let us look at the working. So this is the working as we have discussed. Actual upon apparent. This apparent would be actual minus 80. Using basic algebra, we can find the actual depth to be 320 centimeter. Any doubt, Mr. Sivan?
No doubt, sir.